Hello, my name is Heather Yu, and today I'll be talking about dioxins, commonly known as persistent organic pollutants, or POPs, due to their longevity in the environment. Dioxins are toxic chemical compounds that take a long time to break down in the environment and are therefore long-lasting pollutants. Most of the chemical compounds are identified by their dibenzene ring structures as seen to the right. In this presentation, we will cover a brief introduction to dioxins, the role we as humans play in dioxin production and prevention, exposure to dioxins, and the health risks associated with it, and the bioaccumulation of these chemicals in our ecosystems. On the table of contents, you'll see a brief list of different figures and topics to be covered in our presentation. We will start with an analysis of the 12 most common dioxins, the dirty dozen, and move on to a figure 2, which will illustrate the dioxins released over a 10-year period in grams per year, followed by figure 3, demonstrating a breakdown of dioxin releases by industry, and figure 4, where we will discuss human exposure to dioxins and the health outcomes associated with such exposures. Finally, we will cover bioaccumulation in ecosystems, namely aquatic ecosystems, in figure 5, followed by a summary and our references used in this presentation. Table 1 lists the dirty dozen, the top 12 most common dioxins and their uses named in the Stockholm Convention. In the table, we see that most of the dioxins are used in household pesticides, like that shown to the left, which promotes exposure to humans and the environment. While the US and many European countries have restricted the use of these chemicals in household products, many low to middle income countries like India still use these types of chemicals in their day-to-day lives. The most toxic dioxin in the list is PCDD, a common byproduct in paper manufacturing that is heavily regulated. In the EPA line graph in figure 2, we see the annual dioxin compound disposal measurements in grams over a 10-year period, 2011 through 2020. It is important to note that while dioxin releases themselves have increased by 81% over the illustrated time period, the amount of toxic disposal, grams-TEQ, has decreased pretty substantially, excluding 2014. It is important that we take necessary actions to minimize all dioxin disposal in the future to minimize the health outcomes that are associated with them. In figure 3, we have a pie chart breaking down the dioxin releases shown in the previous line graph by industry. We see that 60% of the dioxins released in 2020 were due to chemical manufacturing, such as tanning and paper manufacturing, while 26% is due to hazardous waste management and 16% is due to primary metal industry. There is an additional 1% for other industrial practices that include burning materials and additional more low-risk release methods. Overall, chemical manufacturing is the primary industrial release method of dioxins into the environment, while there are other natural releases, such as volcanic eruptions and forest fires. Once these dioxins are in the environment, humans become exposed to them in a variety of ways, as seen in the left part of figure 4. Humans can take in dioxins through accidental ingestion, soil, water, other similar substances, inhalation, either air pollution, dust, or similar occurrences, absorption through the skin, or food ingestion, the primary exposure point. 95 to 97% of dioxin exposure to humans is from food ingestion. This buildup in food will be explained in the bioaccumulation quality of dioxins in figure 5, but first, let's cover the health outcomes of exposure, as seen to the right of figure 4. Exposure to dioxins can cause a myriad of adverse health effects such as death, cancer, allergies, sensitivities, central and peripheral nervous system damage, and developmental changes in the reproductive, endocrine, and digestive tracts. Additionally, childhood developmental problems are also seen with dioxin exposure. This is why limiting exposure is necessary. Figure 5, which I have made twice to better illustrate the variables seen in the graph, we see the level of POPs in parts per million in different organisms residing in the Great Lakes aquatic ecosystem. This bar graph illustrates the bioaccumulation of dioxins in ecosystem, as it is clear that the chemicals are obtained by the smaller organisms on the food chain, and as the organism is eaten by a bigger predator, the dioxin levels increase. This is important because it shows why the majority of human dioxin exposure occurs through food, as the bioaccumulation of the toxin allows for organisms in our diet to retain higher levels of the chemicals. The bar graph was created twice because the level of POPs in the top predator, the herring gulf eggs, is so large that it is an outlier in the data, so I have negated it from the left graph to better illustrate the data of the other organisms. Important takeaways from this presentation include the Dirty Dozen, the 12 specific dioxins named under the Stockholm Convention that are heavily regulated for their adverse effects on humans and the environment. Additionally, the fact that dioxin releases have increased by 81% from 2011 to 2020. This alarming pattern emphasizes the need for intervention and further control of the chemicals. Furthermore, it is important to remember that while dioxins are a naturally occurring substance, the majority, 60%, are released into the environment by chemical manufacturing and mainly ingested through food around 95% of the time. Due to their persistent exposure and presence in our environment, it is important to limit exposure as much as possible in order to avoid adverse and sometimes severe health effects associated with the chemicals, such as allergies and problems with bodily systems. Additionally, minimizing fatty foods and fatty animal foods in one's diet can minimize exposure to dioxins and promote healthier lifestyles. Below are the reference websites used to create the graphics in this presentation, along with the statistics referenced throughout the presentation itself. I used a variety of scientific websites, including the EPA and the World Health Organization, but also the World Bank.